If you would have asked me 5 years ago what the on-trend brewing thing would be in 2021, I never would have guessed that hard seltzer water would be so popular. Laugh all you want, but hard seltzer is a fantastic day drinker and likely isn't going anywhere in the near future. Imperial Yeast's new seasonal strain, W04 Paramount, can help brewers get the most out of their seltzer fermentations. A clean and aggressive fermenter, Paramount will produce an excellent seltzer with low fusel alcohols, and it's produced in a gluten-free medium. If you've tried making seltzer with standard ale or lager strains, you know the struggle, and Imperial Yeast is here to help with W04 Paramount. Check it out at imperialyeast.com. Welcome to the Brew Lab. Brewers are always looking for new ways to develop stronger and more intense hoppy flavors. Recently, that's meant research into thiols and biotransformation and high levels of dry hopping. But there's a class of compounds that makes up almost 2/3 of the oil fraction of hops, which packs a lot of hop flavor and aroma. They're known as terpenes. I'm your host, Cade Job, and today in the lab I'm speaking with Dr. Nick Harris from Berkeley Yeast about why terpenes are important to brewers, and also how Nick and the team at Berkeley Yeast developed a yeast strain to maximize the aroma and flavor impact of terpenes. It's funny how many episodes of the show have focused on hops and hop flavor, and how many times we've mentioned thiols and biotransformation, and even on the last episode with Stacey Williams and Justin Alexander, we mentioned that hydrocarbons, meaning primarily terpenes, are the largest fraction of the essential oil component of hops by far. But remember, that episode was about biotransformation. So what's the deal? Why aren't terpenes as cool and popular as thiols? I wanted to get to the bottom of this question, so I asked Nick to come on the show and talk to us a bit about terpenes and why brewers might want to step back and look at how terpenes can contribute. They actually contribute an amazing variety of flavors and aromas to beer. And as we started talking, I realized there was this really cool story about how terpenes were the launch point for Berkeley Yeast. So Charles Denby, Rachel Lee, and Nick Harris, with the startup operating out of Charles's garage, doing genetic engineering that no one else was doing in the industry, they developed a yeast strain that happens to focus on a couple of specific terpenes that we'll talk about in the episode. It's a really fun story that I think you'll enjoy, and terpenes are woven throughout, so hopefully you'll learn some things about terpenes, hop aroma, and flavor, and get to enjoy the startup story of Berkeley Yeast. Hey, if you haven't clicked the button to become a patron of Brewlosophy at patreon.com/Brewlosophy, it'd be really cool if you did. In addition to the feel-good vibes of helping to support the work we do here at Brewlosophy, you get access to a bunch of awesome rewards depending on the different pledge level that you choose. There are really some awesome rewards for even just as little as a few bucks a month. I mean, you can get access to Brewlosophy contributor recipes that we've never published before, new discounts each month to YakimaValleyHops.com, and for the $3 level, access to a monthly live Q&A session with a special guest from the brewing industry. We do a lot of work here at Brewlosophy that's released totally for free, including an experiment and a secondary series article each week, 2 podcasts each week, and starting this winter 2023, the Brewlosophy show will start on YouTube. So check out the announcement at youtube.com/@thebrewlosophy-show and become a patron by visiting patreon.com/Brewlosophy. Another really, really easy way to support us is by using our affiliate links at brewlosophy.com/support. All you have to do to help us out is start your shopping experience by clicking those links. Nothing changes on your end. We just get a small kickback from our affiliates. It's super easy, hassle-free, and all you have to do is start by clicking the links at brewlosophy.com/support. All right, feedback this week is brought to you by the imaginative crew at Haas, who've developed a revolutionary way to dry hop using Spectrum, a flowable 100% hop-derived product that's fully dispersible in cold side applications for great flavor, efficiency, and less beer loss. No solids means less loss, and it's fully dispersible in cold beer, so there's no contact or residency time required like traditional dry hopping. Spectrum fully disperses immediately, so you don't need to wait 24 to 48 hours or worry about double dry hopping, and you don't have to have any special dry hopping equipment. It stores easily, it's easy to use, saving you precious time and getting instant aroma in each batch. It's currently available to commercial brewers in trial quantities of Citra and Mosaic, so check it out by visiting johnihaas.com. That's John, the letter I, Haas.com. And the Brew Lab's resident sensory scientist, Jeff Daly, who works for Haas, is hosting a hop flavorist course in March in Yakima, Washington. It's a 3-day course where you'll learn how to identify and describe the aromas of hops, where those aromas come from, and how to use them effectively. So if you want more information, send Jeff an email at jeff.daily, D-A-I-L-E-Y, at johnihaas.com. All right, listener Masahiro wrote in with some questions about yeast. He said, "Hello again, Cade. I really enjoyed the most recent episode with Dr. Lance Shaner. It's been a mystery to me why wort needs oxygenation. Although yeast cells tend not to undergo respiration in the high sugar environment like standard wort, as discussed in the previous episode with Dr. Maria Mutsoglu." So he's saying, yeah, I mean, yeast need oxygenation, but even though they tend not to undergo respiration. And Masa says, "This is literally an aha moment. Thanks." Well, awesome. That's great. I was hoping some people would have that. And then he says, "Just one thing I'm curious about is if yeast proliferation rate or degree is identical between the aerobic condition and the anaerobic condition supplemented with ergosterol plus unsaturated fatty acid. If there's some difference, there may be some hidden roles for oxygenation, oxygen, respiration, other molecules, etc. Anyway, thank you for doing this. Keep it up. Cheers, Masa." Hey, Masa, this is a very good question, and I can't find any research that answers it. It's very rare that happens when I can't find anything that talks about these differences, probably because Maria Mutsoglu's research is so recent, the low OG starter for propagation. That's such recent research, unlike what Dr. Shaner was talking about, which is the need for oxygen and yeast. That's been studied for a long, long time, and we know not everything there is to know, but we know a lot about that pathway. So it's a really good question. It would be a really cool experiment to run if you had the right conditions. So take one starter with a low starting gravity and lots of oxygen and compare it to a batch with olive oil and ergosterol. The trick, though, like Lance said, is you'd have to get a true anaerobic condition to make a comparison. Otherwise, there's going to be residual oxygen playing a role in there. You'd be sort of testing an aerobic condition versus aerobic plus olive oil and ergosterol, which is also an interesting comparison, but that's more similar to what all of the research out there is, right? That aerobic condition plus olive oil. But anyway, thanks for the cool idea. And if anyone wants to try this, or if you want to try this, Masa, I'd love to hear your results. So, all right, I'm going to take a quick break, and then I'll be back with Dr. Nick Harris talking about hop terpenes and the early days of Berkeley yeast. We all know that designing recipes is really fun, and doing it well is so much easier with good software. We at Brewlosophy recently made the switch to Brewfather, and honestly, y'all, we could not be happier. Brewfather utilizes the latest technology to bring you the most robust cloud-based recipe design software that can be accessed anywhere, on your phone, tablet, desktop, and even offline. It also works seamlessly with numerous third-party devices to make it easier to monitor every step of your brew. I know change can be difficult, but trust me when I say you need to go to brewfather.app today to try it out for yourself. That's brewfather.app.
Established in 1995, More Beer has been consistently serving the greater brewing community since the times IPA was expected to be bitter and clear, and there are reasons they've stuck around so long. In addition to their massive product selection and excellent customer service, More Beer has locations on both the west and the east coast of the United States, which translates into fast shipping times regardless of where you live. And when you spend more than $59, shipping is free. When you're in need of brewing ingredients and gear, there's no better option than morebeer.com, one of the most trusted shops on the planet.
While thiols and biotransformations seem to be grabbing all the headlines, hop oils are primarily composed of terpenes. And guess what? Terpenes have flavor too. So back in the lab to talk with me about terpenes and some GMO yeast that they've developed to highlight terpene character is Dr. Nick Harris from Berkeley Yeast. So Nick, welcome back to the Brew Lab.
Thanks for having me back. Yeah, excited to be here again.
I'm so excited to have you back. It's been a while since we last talked on the show, but we've certainly talked about you and Berkeley quite a lot. So I recently talked with Ricky Molitor, who you know, about work that y'all partnered on, looking at the thiol releasing capacity of some of the new thiol strains that you guys have. And I actually talked about you tangentially in a conversation I had with Matt Winans from Imperial. They're doing some hybridization. We were sort of comparing hybridization with GMO techniques and mentioned the work that y'all are doing. So it's been fun. Like I said, I've talked about you a couple of times, but it's good to have you back on the show talking about y'all's work.
Yeah, well, that was a really great collaboration with both Ricky and the rest of the Shellhammer lab. Yeah, check out the paper if you haven't checked it out yet. But they did some really nice work characterizing the sensory aspects of our tropics yeast, which is really good at releasing tropical tasting thiols.
Mm-hmm. Yeah, exactly. Well, I mean, you guys did the work on making the yeast in the first place, but yeah, it was great. It was a really cool partnership and really cool takeaway. So I'd encourage y'all go ahead and listen to that episode of the Brew Lab with Ricky. And if you've got any questions, Nick is your guy. Also, so well, today we're talking about terpenes, though. That's and specifically Super Bloom. So is Super Bloom one of your original strains, or is it more recent? Where did that come from?
Yeah, I think that Super Bloom was actually the very first strain that we released. And I believe that the first beer that was brewed using genetically modified yeast, that was actually brewed with Super Bloom at Fieldwork Brewing Company in Berkeley, California. So yeah, it was the 20th yeast strain we ever created, and yeah, the first one that we ever commercialized.
Wow, that's amazing. Well, we're going to get into the history of Super Bloom and some of the early days that you guys had there at Berkeley Yeast. But first, I want to talk about you. Just a reminder: so you got a PhD in microbiology from Cal Berkeley, and you started working with Charles Demby and Rachel Lee at Berkeley Yeast, basically right whenever it was formed, right?
Yeah, so I was a grad student getting my PhD in microbiology. Rachel was also a grad student getting her PhD in plant biology, but it's the same department. It's the Department of Plant and Microbial Biology. And Charles was a postdoc. And both Rachel and Charles were in Jay Kiesling's lab, and they kind of kicked off the original research developing yeast strains that produce different terpenes. And out of that work came the company. So Charles had originally applied for a small business innovation research grant with the National Science Foundation. And when that got funded, we had the funds to start the company. And that's when I hopped on board. And I kind of finished up grad school and was helping to start the company simultaneously. So it made for a lot of kind of long days, long nights, but was a ton of fun. And that was about 5 or so years ago.
Yeah, and still going strong. I mean, Berkeley's still going strong. You've got a whole bunch of new strains. Last time you were on the show, we just did sort of, a general review about like GMO yeasts, like what can they do? What are some examples of how we can make GMO yeast? What are some problems that we can solve at a brewery? But I guess I want to ask a question too, before we get too far into the show. What's been going on with y'all since we last spoke?
Yeah, so you're right. We've come a very long way. We started off in Charles's garage. Wow. And so
I can't wait to talk about that one. We're going to save that one for a little later, but yeah, that's going to be cool.
Yeah. So, we started off there and now we have a couple facilities. We've really built out our research and development team. So we have some extremely talented scientists on staff now. We've also moved into the old Giga Yeast facility for that's where we manufacture all of our liquid yeast. And most recently, we just released a new product called Thiol Boost. It's liquid. It's purified liquid thiol precursors that you add into the fermenter alongside our tropics yeast. And when you do that, it just turns up the tropical flavors to maybe a 13 out of 10.
Wow. It goes beyond 11.
Yeah, it goes beyond 11. Yeah, if they made Spinal Tap today, they'd have to change the amp.
Yeah, they'd have to change it to 13. Yeah.
It's very cool. Yeah, I'm very excited about the product. We just finished doing a bunch of brewery trials and have had some really great reception already. And I think it's going to be a really useful tool for brewers to really push guava and passion fruit flavors and aromas in their beer. So yeah, it's pretty neat. It's like a dimmer switch for tropical flavor.
Wow.
The more you add, the more tropical flavor that you can produce.
Interesting. That's really cool. So a new Thiol Boost product. So like putting the precursors in there so that then the yeast can act on it and release those tropical flavors. That's really cool. Yeah. And well, that's awesome. So thiols, and more thiols, it sounds like. But today we're talking terpenes. So we're going to start off the episode just by talking sort of generally about terpenes, what they are, where they come from, get some of that work. And then the fun part of the show, I think, well, terpenes is going to be fun. It's not to say that it's not going to be. But the real fun part of the show is I think we're going to talk about some of the early days at Berkeley Yeast. And so Nick's going to share some of his experiences, what it was like in the early days, where they came up with this idea, Super Bloom, how they found it, how they created it, and we'll go from there. But I guess we should start off then by talking specifically about terpenes. So I'll ask you the open-ended question, Nick. What are terpenes?
Yeah, I think that most people probably are. They probably heard the word terpene, especially if you're in the brewing industry or the cannabis industry. That's really what differentiates most hops, from one variety to the other. They're the smell of, they can have the smell of pine trees. They can smell like grapefruit. They can smell like eucalyptus. If you're walking through a forest, a lot of those smells that you might be picking up on, those are terpenes. So for instance, pinene, that is the aroma of pine trees.
Mm-hmm. Aptly named.
Yeah. Lemongrass, that's a terpene called citral. And so a lot of these really lovely flavors that you can get from hops, or, all over the natural world, those are terpenes, and they can be extremely potent, in their flavor and aroma. They, some of them are more volatile than others. So meaning that some of them might stick around in beer for a long period of time, like geraniol, that, the smell of geranium, can stick around in beer for a long time. And then other ones like limonene, which smells like lemons or kind of citrus, that one will leave the beer very quickly. And so there's been a lot of focus on survivables recently in brewing, and terpenes, depending on the class of terpene, some of them can stick around for a very long time. Some of them might leave, but in general, they create very cool herbal citrus complexity for beer.
Yeah. And I mean, and that's a really important part too, right? Like terpenes are a huge component of hops themselves. I mean, I was just talking with Stacey Williams and Justin Alexander from New Belgium, and they were talking about it can be 50 to 60%. John Paul May, when I had him on the show, they're huge percentages of the essential oil compound in hops. So terpenes are really potent, but I guess I have sort of a question then, like, where do they come from? Is it just in hops or cannabis that they're in, or are they in other things?
Terpenes are produced by most forms of life. Even humans produce terpenes. For instance, we produce the terpene squalene. It's an important component actually in your saba.
Okay.
And insects produce terpenes, but a lot of plants as well. And so I think that that's where most people are familiar with them. Most people aren't crushing up insects and smelling them.
True. Yeah.
But certainly, if you're either familiar with the flavors of beer, or again, if you've ever gone through, a walk in nature, you're definitely familiar with terpenes in that sense. Or the aromas of a lot of flowers as well. Mm-hmm. They're just it's pretty wild too, just how diverse terpenes can be. So, I believe that there are hundreds and perhaps thousands of different terpenes. And so some of them, again, are really familiar, and some of them are totally wild and exotic. And they might contribute flavors and aromas that you're not even aware of. For instance, there's a terpene called guaiacol that to me smells like it's kind of in between a fruit basket, margarita limes, and cedar wood all at the same time. And wow. It's like something you've never even smelled before, but it exists out of nature. And so, and maybe this might ring true to some of the listeners, where maybe you're out there and you break open some plant and you smell it and you're like, wow, I've never smelled anything like that before. And that could very well be a terpene. And so I think what's cool about them is that chemically, most terpenes look fairly similar. They're built out of the same molecular components, but they can have vastly different organoleptic properties, meaning that they can smell different based on just maybe the position of whether or not there's a double bond in one position of the molecule, or whether or not there's an oxygen group on there. And so even though these terpenes come from similar pathways and they can look very similar, the perception of them can be wildly different. And so again, when we're looking at all of these different hop cultivars out there, yes, they might differ in the concentration of thiols that they have, meaning that they might be more or less tropical. Mm-hmm. But the difference between, for instance, Cascade hops and saws might really be the composition of terpenes in there. So, for instance, Cascade has a lot of geraniol, linalool, and citronellol, and those are kind of the primary flavor determinants of Cascade hops. Whereas saws, to me, tends to be a little bit spicier and not so floral and citrus. And so the big difference in those two hops is largely the terpenes.
Yeah.
So it's cool. It's pretty neat. Yeah.
Yeah. I mean, that's a really interesting way to say that too, right? Because I think like myrcene is one of those that's like herbal and spicy, right? That's one of those terpenes that people talk about. I mean, I think it is in most hop varieties the number one component, right, of the essential oils is myrcene.
Myrcene. I think myrcene gets a lot of attention. You definitely see that used in a lot of people will even put it on a label. They'll say, we used hops that were high in myrcene. I think that really comes from the cannabis industry as well. There's been a lot of focus on myrcene. It can have kind of dank flavors as well associated with myrcene.
Yeah.
But to me, I'm personally not a big fan of myrcene. To me, it smells like carrot tops. And I can't get over it. But if you want to know what myrcene smells like, to any of you out there who are wondering what we're even talking about here, go to your fridge, crack open some carrot tops and smell those. That's myrcene. So
nice. And that's the cool part too, right? Like you mentioned, these things exist out in the nature, right? So if you're interested in learning about any of these compounds, if you want to know what limonene smells like, go and smell a lemon, because that's what limonene smells like. I mean, yeah. Yeah,
you're absolutely right. And about 5 years ago, when we were first setting up our analytical lab, and we bought a GCMS, gas chromatograph mass spectrometer, and we were trying to build out standards for all the different compounds that we were interested in. Basically, if you're not familiar with this analytical equipment, every compound in a sample will travel through this machine and be separated out over time. And when it hits the detector, there will be a signal, and that signal will come in the form of a peak. Literally just looks like scribbles on a piece of paper, if you will. And so depending on how much of a compound there is, it will be a bigger peak. And so for a mass spec, all it's telling you is perhaps how a molecule is breaking apart, or it might tell you the molecular weight of that compound, or certain detectors won't even give you that information. It will literally just be a peak, and you will have no idea what it is unless you have a chemical standard. And chemical standards from chemical companies are very expensive. They can be, 20 to hundreds of dollars, or even thousands of dollars if they don't already exist, and somebody has to synthesize a standard. And so for us, when we were first starting out and we didn't have a lot of money, and we were trying to build a long list of chemical standards, I would literally go to the grocery store and buy different fruits and plant material, as well as different essential oils, and do extractions and then run them on the mass spec, and we would be able to build out standards, not for quantification, but for at least knowing that a compound is being detected. We could do it with that information. So, wow. For instance, running a eucalyptus extract on the mass spec, you would see one huge peak, and that would likely be cineol or eucalyptol, which is the essence of eucalyptus.
Huh. Oh, that's interesting. That's so fascinating. It's funny too, because you're just taking regular things, right? You're taking regular grocery store ingredients and using that to identify the smells that you want, right? Identify the compounds and flavors that you want. That's really cool. We should switch gears a little bit, but not too much. But switch gears over to yeast and terpenes, because I want to talk about some of that interaction. So we started off the show talking about this yeast called Super Bloom, which has something to do with terpenes. So why don't we start there? What's the relationship between yeast and terpenes?
Yeah. So yeast, when they're first starting out growing. So I'll bring it back to the brewing process. When you first knock out, so you're going from the kettle into the fermenter, and you cool down the wort, the sugar solution. I'm sure everybody, I guess, listening to this podcast is familiar with the brewing process. But as you're knocking out, you'll aerate the wort. And the reason that you're aerating the wort is because yeast both need oxygen to produce sterols, which are important for membrane fluidity. So having membrane fluidity allows the yeast to transport nutrients inside of the cell. Oxygen also helps with the yeast going through aerobic respiration, so producing large amounts of ATP, cellular energy. But also back to sterols really fast, is a part of that pathway is producing ergosterol. And it turns out that you can branch off of that pathway by inserting genes from plants to produce different terpenes. So branching off that pathway. And so to make Super Bloom, we took genes from both basil and mint, two plants that produce a lot of terpenes, inserted those terpene synthases into a Chico ale yeast. And so while the yeast is producing ergosterol, they will branch off of that pathway, and these two terpene synthases will produce linalool and geraniol, and subsequently citronellol from the geraniol. And so Super Bloom is a yeast strain, again, it's Chico ale yeast, that if you just give it sugar, so this would work with a seltzer or a beer or a wine or a cider, whatever type of alcoholic beverage you're into, the yeast will consume the sugar, and on the way to producing ergosterol, it'll produce these beautiful citrus, floral terpenes. And it's producing mgs per liter, so milligrams per liter of these terpenes. And so the net result is a beverage that, even if you weren't to use any hops at all, it would still have very complex floral and citrus flavors and aromas. And so that's what Super Bloom is doing, and it's a really cool yeast strain. Yeah, it's a lot of fun.
That's pretty cool. So I was going to ask, because we talk about like terpenes and hops a lot. So I'm guessing like hops themselves have a lot of terpenes, but I was going to ask, are there any like special underlying building products that you need in order to make terpenes? And it sounds like for yeast that has this, branch pathway switched on, all you need is sugar.
Yeah, so for a lot of different flavor active compounds like thiols, so all of these compounds are coming from some precursor molecule. In the case of thiols, yeast do not produce the precursors, right? And so you need to have those precursors available and extracted from different substrates, whether that's from barley, hops, grapes, or thiol boost or whatever it is. But you have to get them from somewhere, right? Yeast can't just make thiols from sugars. But certain compounds like esters and terpenes, yeast are already making the precursors, in the case of terpenes, they're through their ergosterol pathway, which is the mevalonate pathway, they're already making the precursors there. And so all we had to do is branch off of that. And so these precursors that the yeast are biosynthesizing are coming from sugar.
Interesting. So yeast itself is able to make these. So it's not like with thiols, like you said, you need something like thiol boost, or you need a thiol precursor that's already present in the beer before the yeast can actually, liberate any of the thiols from those precursors, right? Make those thiols aroma active.
Exactly. And, the same thing, this kind of applies to humans as well. There's certain nutrients that we need to get from our diet because we can't make them. We don't have the biochemical pathways to make those nutrients. And so we end up having to take vitamins and supplements in order to have all of the building blocks that we need to thrive and survive. And so similar for making a really tasty beer, some of the components of making a very tasty beer, the yeast can just make directly from sugar, and other ones you need to add in a supplement or some sort of a building block for the yeast to be able to carry out those the full biochemical pathway.
Right. That's interesting too. It's like there's a very similar pathway that we've talked about, or that I think a lot of brewers are familiar with. That's esters, right? We always talk about certain yeast strains being able to produce esters, like isoamyl acetate or whatever for the Hefeweizen yeast strains, being able to produce that banana flavor. And so that specific yeast has that machinery to be able to make the ester. But like Chico, for example, doesn't necessarily have. Well, it may make that ester, just maybe not in the same concentrations. So is that kind of similar? It's like with terpenes, yeast can do that, or yeast can make terpenes, but they can't with thiols.
In the case of terpenes, the yeast is making they're making the precursors, but they're not carrying it out to the end. So the yeast don't have the ability to make geraniol and linalool.
I see.
Typically, but because we've inserted two new genes, two terpene synthases from plants, now they're able to complete that biochemical pathway. So in most yeast, they would just carry it through to ergosterol or to different sterols. But in this case, they're branching off that pathway and creating new molecules. They're not new to nature or new to your diet or anything like that, but new for the yeast. So other yeast strains can't do that. In the case of esters, all yeast have the ability to make esters. They all have the right genes. So Chico can make isoamyl acetate, for instance. It can make ethyl hexanoate, and it does. It makes small amounts of these esters, and there are certain conditions that might really turn up the production of those esters. Esters are made from typically from the fatty acid pathway. So in the case of isoamyl acetate, that's taking isoamyl alcohol and acetyl CoA, and via an acyl transferase mediating that reaction, it will form isoamyl acetate. And all yeast have different acyl transferases that can conduct that reaction. But some yeast strains might have more active acyl transferases, or they might have higher gene expression of those acyl transferases, and therefore might produce more of them. So the difference between a Hefeweizen strain that's just blasting banana, which is isoamyl acetate, and a Chico ale yeast, which is fairly mellow, might be differences in gene expression of those acyl transferases. It might be the fatty acid complex. It could be how much acetyl CoA is being made. There are a lot of different factors that play into it, but all yeast have that ability, but they might be producing relative amounts for different reasons. But in case of terpenes, you need something else totally, and that has to be inserted into the yeast.
Yeah. The yeast aren't able to make the terpenes unless you take like you guys did, that mint and the basal DNA and insert it into the yeast. So I think that's really starting to click for me. I think I had an aha moment right there about Super Bloom, and one of the reasons why this yeast is so cool, right? Because if you didn't put hops in a regular beer and you just used Chico, you wouldn't get any terpene character. There would be no terpenes performed. But if you make a beer without hops but use Super Bloom, you do get all of this terpene character because you've inserted the mint and basal DNA into the yeast to allow it the ability to make terpenes.
Right. And so the yeast, Super Bloom, will make, if you took the same wort and you were to use Chico ale yeast in one fermenter and you were to use Super Bloom in the other, you would have wildly different beers. Yeah. The one brewed with Chico would be neutral, would taste like beer flavored beer. And the one brewed with Super Bloom would be floral and citrus. And if you had a third fermenter that was Chico with some hop material, let's say Cascade hops, it still wouldn't be identical to the Super Bloom one, because Cascade hops, they contain much more than just geraniol, linalool, and citronellol. They also have different aldehydes, for instance. So they have grassy-like flavors, and they're probably producing hundreds of different terpenes. And so there will be more complexity in the Cascade hopped beer, but there will also be some bitterness created from because hops have alpha acids, beta acids, polyphenols. They can cause hop burn, for instance. And with Super Bloom, it's only producing those terpenes, but no bitterness associated molecules. And so one great way to use Super Bloom, for instance, is brew a low calorie beer that doesn't have a big malt backbone. And if you brew beer like that and you try to dry hop with it, there might be quite a lot of bitterness, even from the dry hop. But with Super Bloom, you can produce, a low calorie beer that has a ton of floral citrus aroma and flavor, be a really crushable beer, and will be very drinkable because it doesn't have any bitterness associated with it. And the flavors are still complex. They just won't be, grassy, or it won't really taste like hops necessarily. It'll just have some of the best components of them.
Yeah. Well, and that makes a lot of sense too, right? Like, because I was just thinking, like, while you were saying that, that's a great application, like a low alcohol beer where you don't have to worry about the increased bitterness. You're using Super Bloom to get those terpene flavors. But it is kind of like what you mentioned earlier towards the top of the show, right? It's like you're layering flavors, right? You're using Super Bloom to layer flavors. You're not saying, oh, great, fantastic, we can make geraniol, citronellol, and linalool using this yeast. Let's get rid of hops entirely. No. That's not at all it. It's not going to taste the same, right? As if you had like Chico and a hopped beer versus just Super Bloom, it's not going to taste the same. But you're talking about layering these flavors. Let's say I want an increase in this citrus character, this geraniol, citronellol, linalool flavors. I want to just amp that up a little bit to give myself something unique. That's where Super Bloom comes in.
Yeah, I would almost think of it as Super Bloom is almost like a single hop cultivar. And so you rarely use just a single hop when you're brewing. I mean, sometimes you do. You might do an all mosaic beer, an all strata beer, or whatever you're going for. But typically, you're throwing in multiple hop cultivars. And so, and Super Bloom can certainly be used that way, where it can be amplifying a general sense of floral and citrus. So I think it's really good as either a standalone and kind of low calorie beers, low alcohol beers, or it can also be used to just increase the overall complexity of a beer that does have hops in it. And so the one use case I wouldn't suggest, though, is dry hopping with 4 to 6 pounds per barrel with the Super Bloom, because in that case, those hops are really going to overtake it, and you won't really smell, their diminishing returns, and it might kind of muffle what the yeast is doing, which is fine, but it's it might be a little disappointing if what you're trying to do is really taste the difference of having a beer brew with Super Bloom compared to a beer that's not, and you have all these hops that are just covering it up. The other use case scenario that I don't really suggest is going really tropical with it. So if you're really trying to push styles, for instance, I think it can kind of clash a little bit with the Super Bloom flavors, which are more floral citrus. So I think Super Bloom's really good in pale ales, West Coast IPAs, clear beers primarily. Really good for blonde ales, just good summer crushers.
Yeah.
But I wouldn't use it in a huge DIPA like hazy. It's not the best use case for it.
Right. Like I was going to ask about these hops like Citra and Sabro and Mosaic and stuff that have these huge tropical, flavors and stuff. That's not necessarily something that I mean, those are just different compounds, right? I mean, those hops have different compounds that are driving their aroma characteristics, right? It may not necessarily be the terpenes that are driving, or at least those specific ones, geraniol, linalool, and beta citronellol that are driving that character, right?
Yeah. In the case of Citra definitely has some thiols there that are creating some tropical, nice tropical flavors. It might be producing it might have other terpenes that are more citrus. Sabro, to me, tastes like a lactone, that kind of coconut flavor that you can get from it.
Yeah.
It's kind of like a creamy coconut. But that could definitely be a terpene. Again, terpenes are so diverse and there are organoleptic properties that I wouldn't be surprised if that is a terpene. But I think that those hops, if you're really trying to push tropical, I'd recommend using a yeast strain like Tropics, which is producing complementary tropical flavors. So again, Tropics is producing 3MH and 3MHA, which are responsible, those are primary flavor determinants of guava and passion fruit. So guava, passion fruit with a little bit of coconut from the Sabro. I mean, now you're talking tiki drink, that's,
yeah.
I think that's where most people want their hazy IPAs to be is in the tropical realm. And floral citrus, that we can save that for those West Coast IPAs.
Right. Well, all right. And then so last question before we head to the break, I wanted to ask, I started off the show talking about thiols and biotransformation as being the hot topic, but this actually is a form of biotransformation, isn't it? Or when we're talking about super bloom and this terpene production?
I think the word biotransformation gets thrown around a lot and can mean wildly different things. And I think, there's a lot of talk about active fermentation dry hopping, for instance, for biotransformation. And I don't really know, I think that word means something different to everybody. So Super Bloom is doing a type of biotransformation in that it's taking in sugar from the malt and converting it into flavor active compounds. There can also be biotransformation could mean cleaving glucose molecules off of terpenes to create terpene alcohols, something that some people talk about. And then biotransformation often is used in reference to the biotransformation of thiol precursors into free thiols, so flavor active thiols. But it could also, it can mean a lot of things. But yes, it's doing a form of biotransformation in that if you didn't use Super Bloom, it wouldn't be producing these molecules. You add Super Bloom and it's biotransforming, sugar, a carbon source, into something that's more that you can perceive and enjoy and has a flavor.
I think it was either Stacy or Justin on the most recent episode where we were talking about mid fermentation dry hopping, which is another one of those that you just mentioned. I think it was either Stacy or Justin. One of them joked that the conversion of sugar into alcohol and CO2 is biotransformation. We call it fermentation, but
it can mean so many things to different people. And I personally, I'm not a big advocate of active fermentation dry hopping. I think you'll probably not see the return that you're hoping to get from that practice. I think if you want to push thiols, it's important to have those precursors at the start of fermentation. So that's why we recommend adding thiol boost in at the very start of fermentation. If you were to add it in later in fermentation, there would be less of an effect. Dry hopping on top of yeast is not good for yeast health. You can't reuse that yeast, or at least you shouldn't repitch it. You'll see viabilities drop off quickly if you do that. So I personally always recommend let fermentation proceed, harvest the yeast once you're at terminal, pull the yeast out of the fermenter, then dry hop. And then that way you have happy yeast and you're still extracting a ton of flavors from those hops, and I wouldn't be so concerned about biotransformation.
Right. I think Justin and Stacy would agree with you, and that's probably a good place for us to take a break. So we'll take a quick break, and then we'll be right back talking about how all this stuff started at Berkeley Yeast. So hang around just a second. One of the biggest improvements to my brewing practices was the upgrade to stainless steel, and Delta Brewing Systems offers some of the lowest prices on high-quality stainless gear, like the Firm Tank, which holds 8 gallons or 30 liters of wort, comes with a domed lid to reduce the chances of a messy blow-off, and it can hold up to 4 psi of pressure. Delta Brewing Systems also has their own line of brew kettles, as well as one of the lowest-priced all-in-one electric brew systems out there, and their prices are remarkably affordable. If you're in the market for legit stainless gear that won't break the bank, you've got to check out deltabrewingsystems.com. Hops are known for the variety of pungent flavors that they contribute to beer, from fruity and tropical to spicy and herbal to berry, pineapple, coconut. There's quite a range of aromas, and as we discussed in the last segment, terpenes are a large fraction of the essential oils in hops and responsible for a lot of those aromas. So Nick, I guess since we're talking about the origin story here of Berkeley Yeast, is that why, one of the reasons why y'all decided to look at terpenes first?
Yeah, so the terpene story is that Charles and Rachel are coming out of the Jay Kiesling's lab at UC Berkeley, and that lab had historically focused on producing terpenes for both medicine and for biofuels. Turns out that some terpenes are good to burn. And Charles, he was actually homebrewing at that time. And I think he was reading George Fix's book, The Chemistry of Beer. I can't remember the exact title, but is that book with the molecules on it, with the glass of beer on it. In that book, there's a chapter about terpenes, and Charles was reading that book, and he saw linalool and geraniol, and he said, "Holy cow! Those compounds are so similar to the ones that I'm currently producing in Jay's lab." And that was kind of the aha moment for Charles. And so both he and Rachel sought out to engineer yeast to produce those terpenes, with the goal of creating a beer without hops that would still have hoppy aromas and flavors. And so they went on to publish a paper in Nature Communications. It was a collaboration with Lagunitas, who did this some of the sensory work. Brian Donaldson over there kind of led the charge with the sensory work, and also with Charlie Bamforth. He did the pilot brewing with Joe Williams at UC Davis. And so as a part of that, they brewed several beers. One was a Chico, all Chico beer, no dry hops. One was Y2, so the predecessor to Super Bloom, which was the second yeast strain that was ever in our collection. Super Bloom was the 20th one, so it was Y20.
Okay.
And then they also brewed a beer that had Chico ale yeast and some Cascade hops. And with the sensory analysis done at Lagunitas, the beer brewed with the terpene producing yeast was rated as being hoppier than the beer that was actually dry hopped.
Oh, wow.
It was, so anyways, that was kind of the origin of producing that yeast. And I think that paper and those results kind of inspired all of us that into thinking that there was, a business case to be made, and that genetic engineering could be used to have a real impact on beer quality and flavor. And so that was the initial premise of the company, was yeast that produce terpenes. And from there, we started the company with just a small grant from the National Science Foundation. And that was enough to build out a lab in Charles's garage with some used equipment from eBay.
Nice.
And we bought some SS Brewtech fermenters, and I would go to grad school during the day and work in the lab there. And then at nighttime, I'd go over to Charles' house and solder together different parts, and built out a glycol manifold to cool all those. To cool all the beer. And we would go around. We didn't have a brew house or anything like that because it wouldn't fit in Charles's garage. And so we would go around to local breweries like Fieldwork and 21st Amendment, and they would give us wort. They would fill up corny kegs. So go over there, fill up 6 corny kegs of wort, bring it back to Charles's garage, dump all of the wort out into a big Bubba barrel. It's like a 55-gallon stainless steel container.
Yeah.
And then we had this huge mixer that we put on a drill, and we'd mix it up. We were really into having controlled experiments with homogeneous wort, making sure that all the fermenters were the same. And so we would mix it up with this big drill and send it to the different fermenters. And then we would do controlled experiments where we would add different yeast strains, with one fermenter always receiving the parent or the non-engineered strain, and then 5 fermenters receiving different engineered strains.
Wow.
We would then keg that beer and then bring it back to the breweries that had given us the wort. And we'd have these hilarious meetings where we'd roll into these breweries. Like I remember rolling into Fieldwork with 6 corny kegs full of beer into their little conference room there, with a CO2 manifold and, tap. And we were pouring pints of beer. And I remember them saying that, wow, this is the most beer anybody's ever brought into our brewery. And so we would pour beer samples for them. And they would give us feedback, and they say, wow, this is cool. Or could you do could you produce more of these flavors or these aromas? Or, have you guys considered making yeast that, you know, fill in the blank? And, we'd frantically scribble down notes and then take it back to the lab and try to iterate on those strains.
The lab in Charles's garage.
Charles's garage. And then we ended up moving into kind of it was like a work-in studio type space where we would actually wash all of the lab glassware in the bathroom. That's how small the place was. So it had a little office upstairs for any important business calls or anything like that.
Yeah.
Where you actually had a glass door, and you walk down the stairs, and then we had our lab benches that Charles had built. Charles is a pretty handy carpenter / plumber / electrician, and so he had built our lab benches, and it was pretty cool. We had, I think, just a couple other employees at that time. And then we ended up applying and winning more grants, doing some fundraising as well. And then that allowed us to move into our spot in West Oakland, which is where our R&D lab is still. And we've since built out the R&D pilot facility. So now we have 18 5-gallon fermenters. We have a full-time pilot brewer who's Anthony Lopez, who he was at Magnolia before becoming our pilot brewer. So he's brewing just killer, really clean beers, really good background for testing out different yeast strains. We now have a full, we have a bunch of different scientists who have different specialties in either chemistry or biochemistry or structural biology or genetics. We have a bunch of different research associates who are doing the real hard work of creating all these yeast strains. And then we've also built out an analytical lab as well. So we have an LCMS and a GCMS and another HPLC with a couple different detectors on it. We have plate readers, and it's turned into a real research institute, if you will. And every day we just get to play around with different yeast strains and bring creativity, and it's really a lot of fun. So.
Man, I love hearing startup stories. That's always so much fun. It's I guess all you guys needed was like the pool table in the garage as well, right? I think that's the only thing that's missing is like the pool table that you can play on while you're downtime in your fermentations or something.
We had a cat. We had Charles's cat. So you'd be there, trying to be as sterile as possible, or careful with sampling, and then all of a sudden this cat would just jump on your shoulder. Merle is the cat's name.
Merle.
I think he actually has his own Instagram account.
Oh, okay.
Merle, he was always there late at night. Yes, we had our little cat. We've never had a pool table, but
Merle the cat. Yeah. That's great.
Merle the cat.
Well, and you did tell me a story too off air that we've got to get on air. And you told me the story about the truck that you had to transport of this beer around.
So Charles had this Honda Accord. He actually ended up giving it to me a few years later after it was the truck. And it died recently. Actually, somebody cut the catalytic converter out of it in Oakland. And totaled it. But this was our company truck, and so we transport fridges and industrial sinks and pretty much anything that we could strap onto the top of this truck. We would. Right.
And just so that listeners didn't miss it, right? We're talking about a Honda Accord here, which is not a truck.
Yeah, it was a Honda Accord.
It's a 4-door sedan.
It was.
That's awesome.
Those are pretty wonderful cars, and they can tolerate a lot of abuse. And so. Yeah, that was pretty fun as well.
I can just imagine you guys loading that thing up with 6 different kegs, of all this, 6 different cornies. I don't even know how there's space for it, but maybe between the trunk and the back seat, you can fit everything with all the equipment and CO2 tanks and everything.
Yep. Yeah, you could probably fit more than 6 in there. You could fit 6 in the trunk, and then you could fit at least 1 chest freezer on top. Yeah.
Just a chest freezer on top. That's
they're
amazing.
pretty amazing.
Well, and I guess that explains how you built out the garage then too. So I mean that's pretty cool, right? You've got these different fermenters. In the garage, you've got corny kegs that you're taking around to breweries. So tell us, like, how did Super Bloom come out of this? You mentioned that it was the 20th strain, but what's the story? How was Super Bloom discovered or developed or whatever?
Yeah. So when we first started the company, so again, Charles and Rachel had created the first prototype at UC Berkeley. And then when the company started, we really focused on terpenes for a long period of time. And so we would try inserting different terpene synthases from all over the plant world into yeast and would kind of coax them into producing a wide variety of terpenes. So far more than just linalool and geraniol and citronellol. We were producing cineol and guaiacol. We tried with limonene, and the world of terpenes again is expansive. And so, anyways, we hit the ground running, creating a lot of different terpene strains. And as a part of that, we first really focused on just modulating gene expression. Using that Y2 strain as the backdrop. And so what I mean by modulating gene expression is that we would try turning up the expression of these two different terpene synthases from basil and mint so that the yeast would produce more of the active enzyme and therefore more of the resulting terpene. So you can think of modulating gene expression is kind of like a dimmer switch, if you will. So we would build out different yeast strains that had a different setting on this genetic dimmer switch, which would each resulting strain would produce a different concentration of the resulting terpenes. And so what we ended up doing was we created a whole suite of different yeast strains that produced linalool, geraniol, and citronellol. And then we had the guys over from Lagunitas come visit our lab in Berkeley. And we poured them some beer samples. And again, they had already participated doing sensory analysis for us. So they were familiar with the concept of terpene producing yeast strains. And when they came over, we poured them Y2, we poured them Y6, a few that were fairly mellow, fairly tame. And I remember watching them and Jeremy Marshall, he's kind of drinking these beers and they're like, oh yeah, that's good. Okay. They're kind of underwhelmed, to be honest. And they're like, okay, cool guys. This is great to see you, whatever. And I said, hold on, we have one more for you to try. And we had run all of these beer samples on the GCMS. And so we knew, the different concentrations of all these terpenes. And there was one strain, Y20, which we had really cranked up the concentration of terpenes far beyond what Y2 was. And it was on paper, it looked like it would be gross. Like it looked like it would be producing too much terpene character. And we had actually done some sensory analysis in-house. Sensory analysis, we had poured some beers and drank them. And we thought it was really intense. And so anyways, we had chosen not to pour that beer for the Lagunitas guys because we thought it was too much and that nobody would want it. And but because they were so underwhelmed with Y2 through 19, I said, hold on, one more beer, poured them Y20. And I remember watching Jeremy drink this beer and he drinks it and he says, that's what I'm talking about. Like, you guys got to keep on blasting that flavor. Like, you'll know that you're successful when somebody drinks one of a beer made with your yeast and they spit it out uncontrollably because it's just that potent. And that's what you guys should be going for. But this is awesome. So that reaction from him totally changed the way that we had thought about making yeast strains. We had really focused on making, subtle changes in the yeast. And that was kind of another aha moment of, man, we need to create yeast strains that are blasting flavors and aromas, that brewers can really tell a difference between the parent strains. So, right now there are so many different yeast strains out there and so many of them are just subtle, subtly different from the other one. And you can just switch out, it doesn't really matter if you use, an O1 or an O2 or an O3 or whatever, right. Fill in yeast company name. But that was the realization, is that we really had to create yeast strains that were distinctive. And we ended up taking Y20 based on Jeremy's reaction to it around to a bunch of breweries. And we used to show up to these breweries and pour them Y20, and we would get the same reaction from these breweries. And so
Nice.
I remember going over to Almanac, for instance, and our buddy Phil, he tried the beer. He's a brewmaster there originally, and he's now at the olfactory, but and he just lit up. He was like, whoa, this is so wild. And he actually got out his camera, called over David, who was his assistant brewer at the time, and said, David, you have to try this beer. And he started filming him to get his reaction. Because, at the time, nobody had tried any GMO yeast strains before.
Mm-hmm.
This was totally new. They weren't kind of primed to have a specific reaction. And so when all these brewers were trying these beers for the very first time, it would kind of blow their minds of what was possible, because they had never tried a yeast that was producing big floral citrus aromas, similar to when we first made Tropics. People had never tried a yeast that was producing guava and passion fruit. And so,
yeah.
It would just blow people's minds. And it was so much fun in those early days to experience that. And I think that was really inspiring for all of us as well, to really see that what we were creating was having such a huge impact on people, whether or not they wanted to use these yeast strains for making beer. Just knowing that there was a potential for them to, we kind of knew that we were breaking ground in some way. And that was just a ton of fun in those early days. And anyways, that's kind of the full story of Super Bloom, and it ended up becoming a fairly popular strain, and we still sell it today. And that was the 20th yeast strain we made, and we've now created thousands of different yeast strains. So Tropics, for instance, was our 989th strain.
Okay. Yeah.
Chill Tropics was our 1000th, 173rd strain. I've just memorized all these weird numbers in my brain now. I'm like, I get nostalgic. I'm like, man, Y135, that was a nice one.
You're like Y20, the OG.
Yeah, it's the OG. And for a while we called it Y20, and people would, I remember 21st Amendment brewed a beer with Y20, and they called the beer Y20.
Oh, okay.
And that just like totally rocked our worlds at the time. Oh my gosh, this is so cool. There's a beer named Y20. Like, whoa, like
that's cool.
We're gonna do it.
Yeah. Oh man, that's so much fun. Like I said, I love startup culture, because that's like so fun, especially whenever you're doing something really cool and really unique, like making that yeast with Super Bloom. I do like the name Super Bloom. I love it, because I think that's a great description of what that yeast is going to smell like. And I do remember, I mean, we was talking with, we mentioned earlier the study that we did with Ricky, right? So I've smelled through some of those Tropic strains. I was on the sensory panel, and holy crap, those things are so potent. They smell so good. Like, it's really awesome. I mean, I know I've actually had a couple of people write in that are interested in getting homebrew size pitches. I don't know if y'all have that on the horizon. I won't put you on the spot on air to talk about that, but it's definitely something that homebrewers are also interested in. But it's that pop of explosion, that explosion of flavor that's so cool. And it's really interesting to think, there's also, one of the things I talked with Matt Winans about with hybridization is you go through a lot of steps, right? In doing hybrids, you have to make a lot of different yeast. You have to narrow it down. And you're kind of doing the same thing here, right? Like, even though you're using like CRISPR or something to edit, gene expression, you're still having to modulate and pick the right synthases and pick the right DNA codes and put it together in a way that makes sense and makes things interesting to brewers.
Yeah, there's certainly a lot to it. Even if we know the compound that we're going after, the molecule that we're going after. So in the case of Super Bloom, linalool, geraniol, citronellol, even though we have those targets in mind, to create that strain, we had to generate a lot of different versions with different terpene synthases, and to identify the ones from basil and mint that were highly active and precise in their activities. And then beyond that, it's modulating gene expression to turn up the expression of those to produce more or less of the resulting of the encoded enzyme. And then there's a lot of playing around with different parent strains as well. So, and some of that early on, we didn't really know what brewers would want to use. And so it took us a while to find London, for instance, which is Tropics. We have a bunch of different Tropic strains now, but the London is definitely our most popular one. And we learned that along the way. And so, but just because you have an idea that, for instance, that London will be popular for making hazy IPAs, it doesn't necessarily mean that you can use the exact same strategy that you used in Chico and apply that to London, because London might work better with different enzyme variants, or it might work better with different levels of gene expression, or it might you might need to coax it into transporting some precursor into the cell. These yeast are wildly different, and so anyways, there's a lot to it. It's not just a concept and execution.
Right.
Sometimes these projects can take a month, sometimes they can take years, and it really depends on how complex the project is.
I was going to say, it sounds like one, there's a whole lot of research that has to go into it, right? I mean, and research not just in terms of like, okay, I'm going to actually make this yeast cell and we're going to brew it with it. Research in terms of what even exists out there that we might be able to incorporate, or what is even a flavor that brewers might want in beer. So it sounds like you've got to do a lot of like consumer research. You got to do a lot of reading research, analytical, all of that.
Yeah, there's a lot to it. And you're right. It definitely starts at the brewer level. So we'll go out and they're getting this information from consumers. So a brewer might tell us, that pineapple flavor is a really big one, just as an example. And then we might have to think about what that is, and that would be reading papers about what pineapple flavor is. And then our science team would have to then find different enzymes that are capable of producing those molecules. And so it definitely starts on the front lines of talking to brewers and really figuring out what's cool and popular, what might be popular in a couple of years from now, and then handing it off to our science team. And again, we've really recruited a lot of talented people to run that side. So that's almost the easy part now. But
right, yeah,
there's so much to it, and then it's not necessarily trial and error, but it definitely involves a lot of highly controlled experiments and being extremely methodical in how we go about generating all of these yeast strains.
Right.
And so, but even with an extremely talented team and a lot of really fancy equipment, it still can take a long time if it's a difficult trait.
Well, and it's still also thinking like off the wall too, right? Like, for example, I'll use Tropics as a great example, right? Tropics is a strain that you can use it by itself with just base malt, and it'll create tropical flavors, which is pretty awesome, right? But then you start thinking about, well, hey, how can we modulate this even further? And enters thiol boost, right? And this is like, okay, now we've got a dimmer switch. We combine these two together, thiol boost with tropic, and suddenly, boom, now you've got a way that brewers can control the tropical flavor using that yeast.
Totally. Yeah. So for some flavors, you might be able to just turn up gene expression, especially if they're producing these flavor molecules from sugars, because there's no limiting precursor in that case.
Yeah.
But with tropics, it's taking in precursors from typically barley and hops and converting those into free thiols. But those the amount of precursor molecules that you can get from those ingredients is limited. Yeah. And so the easiest way to continue to turn up the tropical intensity is by adding in more precursor. The issue for us is that, and the reason that we developed Thiol Boost is that if you're adding in more precursor and it's just from a whole plant, you're also getting a lot of other flavors.
Yeah.
Right. Yeah. And so it doesn't matter where it's coming from. Plants have all sorts of other stuff. They might have dank-like flavors. They might have grassy flavors or bitterness or,
the polyphenols.
There's a lot to it, right? It's plant. They're super complex. And so for Thiol Boost, what we've done is we've actually done an extraction and then a purification process where we're pulling out only the precursors for 3MH and 3MHA, and that's it. There's nothing else there. And the reason that we're pulling out just the precursors to 3MH and 3MHA is because those two compounds smell like guava and passion fruit, and they don't produce any of the other flavors that you might not want. So it's just a clean expression. It's a complex flavor as well, but it's complex but clean. It's only hitting the type of tropical that people want in a hazy IPA. And so that's the major difference and that was the challenge of how can we load up wort with precursors, but leave all the other stuff behind that we don't want in that beer. And so that's what's cool about Thial Boost is just a clean expression. It does require the use of tropics though, so you need a yeast strain that has a very highly active carbon sulfur lyase, and so you need tropics. But when used in conjunction with tropics, it will be super guava, passion fruit. If you don't use tropics, nothing will happen. A non-engineered yeast strain, even if you take a wine strain that you think is highly active at producing thiols, like a Sauvignon Blanc strain, there still will be minimal effect. So really to get, a lot of tropical out, you want to use tropics.
Yeah, interesting. That's cool. And it is, you make a really good point that's sort of a key takeaway from this episode, right? As we talk about terpenes, it's that increasing terpene character, because the substrate is sugar and wort has a crap load of sugar in it, upregulating the gene expression is all you need to do to change the expression of the different, terpenes that you're looking for. You need to find the right synthase, right, and then regulate that expression. But like thiols requires the precursor. That's your limiting factor.
Yeah, so different biochemical pathways can have different bottlenecks. And what I mean by bottleneck is that there might be some part of the pathway that's really efficient, but there might be some part of a biochemical pathway where it gets hung up. And so at that point in time, where the bottleneck is, that's what you need to surpass in order to keep on producing more and more of whatever compound it is. In the case of thiols, the bottleneck is that specific precursor. But for terpenes, the bottleneck happens or further downstream. It happens at the actual terpene synthase. And so by increasing the expression of that terpene synthase, or by swapping in a more active terpene synthase, you can produce a higher concentration of terpenes.
Yeah. Well, and this is cool too, right? I mean, this is obviously the continued growth of Berkeley is going to be looking for new compounds, new flavors, and continued expression of the things that brewers want, right? More terpenes, more thiols, whatever we're looking for, I guess, right? That's the future.
There's a whole world of flavor molecules out there.
There.
I mean, just walk outside or into your grocery store and not everything do you want in beer, but certainly there's a lot of room for innovation in the brewing industry. And there are a lot of different tropical flavors, for instance, or a lot of different citrus flavors. There are a lot of I think there's a lot of opportunity to use genetic engineering to push the production of those different flavor molecules. Sometimes that's easier than agriculture, for instance. Like last year, the berry crop, for instance, really suffered. It was difficult for people to get raspberries. You could have a yeast strain that produces raspberry flavor. Or sometimes consistency is important. So if you have a brand that requires certain agricultural products, and those agricultural products either change or the yield is bad that year, that might affect the product you're making. So I think that having yeast produce these flavors is kind of a neat solution to that issue. And the goal is not to replace agricultural products. For us, we love hops, for instance, but I do think that there's a lot of room for increasing the complexity of beer with using yeast synergistically alongside agricultural products. Or in certain cases, maybe there are certain case scenarios where you do just want to have the yeast produce some compound because maybe it's not feasible to obtain the agricultural product, or the agricultural product might have different off flavors that you don't want.
Yeah, interesting. So again, it's using that yeast to dial in the flavor, not to replace, but to dial in and augment and make the flavors that you want in beer. Well, we've spent a lot of time talking about terpenes. We talked about some of the history of Super Bloom, and I always ask this question before we end. If you want brewers to take away just one thing from today's episode, what would it be?
I would just say that I think that the future, the future of brewing is going to be really cool. And I think that more than ever right now, there's a lot of innovation occurring in the beer industry. And whether it's with our yeast or some other product, I think that people are just kind of going, there's just so much innovation occurring right now. And I would just say that if there's one thing I want you to walk away with, is that this is a really cool time to be a beer drinker or a brewer. More so than ever before.
Yeah, and I'll add, don't forget about the terpenes, right? They're a huge part of hops, and they're a great thing. A really good flavor. So, well, Nick, is there anything else that you wanted to share that we didn't get to talk about today?
I don't think so. Thanks for having me back. And if you have questions, feel free to reach out to me. Go to our website, fill out the contact form, and I'm sure I'll see that email. So always happy to hop on the phone with people. And if you are a home brewer, talk to your homebrew club. We love partnering with homebrew clubs. We'll often send out yeast, and then we'll do a little talk so that you can be drinking beers brewed with our yeast that you've brewed. And then we'll kind of fill in some of more information about the science behind it, so you can have a greater appreciation for what you're drinking and brewing.
Hey, that's really cool. You should definitely take up, Nick, on that offer and see if you can get your hands on and brew with some of these yeast as part of your homebrew club. So, Nick, thanks again for your time, and thank you so much for joining me in the Brew Lab.
Awesome. Thanks for having me.
All right. Well, listeners, in the show notes, you will find a link to Berkeley Yeast's website where you can check out Super Bloom and all the other innovative yeast solutions that Berkeley Yeast has to offer. And if you enjoy this content, please leave a review wherever it is that you listen to podcasts. And don't forget to check out our other show, the Brewlosophy Podcast. The Brew Lab is a production of Brewlosophy, where they who drink beer think beer. Don't forget to visit brewlosophy.com to read about our weekly experiments and other brewing adventures, and listen to us talk about it on our other show, the Brewlosophy Podcast. Thanks to all of our sponsors and patrons that help make this show possible. If you'd like to receive a reward for helping us do what we do, visit patreon.com/brewlosophy to see how you can do just that. Thanks so much for listening. We'll be back in the Brew Lab with another guest next week. Until then, think beer.